Hello, my name is Rob Ayala, and this is Mark Montgomery. We're with Lubrication Engineers, and we're here to present lubrication best practices, in specific selecting grease and automatic lubrication. We'll talk about three things here. Talk a little about lubrication engineers, the best practices when selecting grease, and then talk about single point automatic lubrication. So a little about lubrication engineers. They started in 1951 out of Fort Worth, Texas. We're now located in Wichita, Kansas, where we manufacture grease and oil. We also have a state-of-the-art laboratory. It's over 6,000 square feet, where we do our own research and development. We test our products for quality. We even benchmark them against other manufacturers. What makes us unique are these four proprietary additives: Anisole, Monolec, Duolec, and Quinplex. Outside of our premium quality oils and greases, we also offer a full line of reliability products and services. So we have training, we have reliability assessments for equipment, we have oil analysis, bulk storage, transfer containers with lids that screw on and you can pump out of. We have we have grease guns with clear sides so you can see what type of grease is inside. Here's a single point automatic lubricator. There's a breather for your gearboxes that has desiccant media and a 3-micron filter. We have filter carts. We have oil sight glasses. An example of kind of what we do for the customer is we may clean up a oil storage room. So as you can see on the left, this is a little disorganized, maybe a little dirty, just doesn't look nice, and we can help a customer clean that up by providing them a nice bulk storage tank unit. As you can see, these color-coded tanks are color-coded to what the grease, or excuse me, what the oil that's stored in it is. This particular one, they have a quick disconnect. You put a line on here, connect it to a stem. You can take your oil out of your barrels. It'll pump it into the tank, and then when you want to use it, you simply use the bar tap. It pumps it out of the storage container through a filter, put it in your transport container, and you get to go out to your gearbox with a nice, clean transport container that's not going to allow dirt or anything inside. Another example, so if a customer has a large gearbox that maybe they don't want to change the oil just based on 3,000 hours, go from a time-based maintenance to a condition-based maintenance. Take a oil sample. If this sample comes back and says that the grease or the oil is, still good, maybe it just has more particulates than it really should, then we can put this filter card on there. As you can see, we have quick disconnects, connect up to the filter card, just do a loop system while the equipment's running, run this for 2 or 3 days, come back, take a sample. If the sample is good, we can take the filter card and use it in another area. Another best practice that we kind of go out and help the customer do is we put a lot of automatic lubrication on equipment. Under these covers is a automatic lubricator that lubricates this piece of equipment continuously, remote mount, so it's easy to get to. This is a great solution to any conveyor, anything that runs for an extended amount of time. All right, so on to grease. How do you select your grease? So if we go out to a store to buy grease, then this is where we would kind of know what are we looking for? What are we going to buy? Well, first off, we'll give a little data on what's in a grease and some of the variables that go into what a grease manufacturer can use before before we find out what's actually the best grease. So some of these variables would be we have a base oil, we have a thickener, and we have additives. So a grease manufacturer has it's always, let me back up. The variables of the grease. So let's see what is in the grease. So we have a base oil, a thickener, and additives. So out of all these ingredients, it's always a fight between what ingredients to use that a grease manufacturer has. So do we want this to be a value, or do we want this to be more for performance? Do we want this to be for general purpose or more of a specific application? Do we want it for a low speed bearing, a high speed bearing, food grade? The list goes on and on. But some of the variables that a grease manufacturer has that can change are the base stock. This could be mineral, it could be synthetic. And mineral would probably would use a base stock that comes from, say, a group 1 to a group 3, and that refers to how well it's refined. Synthetics are typically a group 4 and 5. And what we're getting with the amount of refinement is we're refining out all the properties of the oil that we don't want. We're getting out the waxes, we're getting out the solvents. And what that means is a group 1, that's the lowest amount of refinement, is going to have a viscosity index that is fairly low. It's going to be it's not going to perform as well in changing conditions. So with a lower viscosity index, it's going to be thicker when it's, say, cold, and when it's hot, it's going to thin out more. But if we refine that oil more, go to group 2, go to group 3, especially if we go to synthetics, our viscosity index starts going up, and what happens is our performance greatly increases, and no longer does our oil start to thicken up at those cold temperatures. It no longer thins out at the hot temperatures. So in general, as the low viscosity numbers in a group 1, it's less expensive to produce that. And as we go up in the groups, we have a higher viscosity, costs a little more to make that base stock. So those are some of the variables that we can change when we're making a grease. Just as a little side note, you can see this group 3 is in with the synthetics, and that's because in the recent years it has been established that group 3, highly refined group 3s, can actually be called a synthetic when it actually came from a crude minerals stock, but it's just heavily refined. So these thickeners, what are they? They're similar to a sponge. It's a 3D network of pores that absorb the oil, and under pressure release the oil to do the lubrication, and then when the pressure is released, it gets reabsorbed into that thickener. So from the grease types, as you can see, there's lots of different grease here. How do we know what type these are? Could we tell from the name? Could we tell from the color? Not exactly. We need to know what type of grease we're using. So this thickener, that's what's going to tell us the type of grease that we're using. So we have a lithium complex, we have aluminum complex, calcium complex, a polyurea. That would be what our type of grease that we're using. So the important part about this is the compatibility. So you can go out to the internet and find a compatibility chart that will tell you if if these thickeners are compatible with each other. And in some cases, you'll find that they're not, and you really wouldn't want to mix these. So as an example, the lithium complex over here on the right, we can see is compatible with most other types of greases, whereas a polyurea is not compatible with most any other grease. Now, how thick your grease is, that's an important part of the grease. And we express this in an NLGI number 6 all the way down to 000. For reference, a 000 thickness would be something like cooking oil, whereas a number 6 NLGI number would be something like cheddar cheese, like a solid lubricant. And in the middle you can see, here's our NLGI number 2, similar to a peanut butter. So the last component of this is our additives. So a manufacturer can put many different additives in there. Maybe we want one for water resistance. Maybe we want one for anti-wear. Maybe we want one for extreme pressure. As you can see, here's one for solid additives. An example, you could have graphite in there, palladium disulfate, otherwise known as moly. You could have Teflon, or you could have what this one on the end is aerosol. That's a proprietary additive. So now let's with this knowledge, let's apply the best practices when selecting our grease. And what we like to use are the 5 R's. So the 5 R's are the right lubricant, the right amount, at the right time, in the right place, in the right condition. So starting off with the right grease. Again, which one of these greases are the right one? Well, we can probably find out what type they are, but how do we know which one to actually use? Well, we probably need to go and look at a specific application. Here's a good example. This is a bulk material elevator. We have a shaft going through there, and we have a bearing, and this bearing happens to be a Dodge with this part number. The dimensions of the inner diameter of the shaft, the outer diameter of the bearing, and the width of the bearing. We have a temperature. We have a condition exposed to moderate rain and dust, speed of somewhere around 100 RPM or less, and a moderate load. So if I was looking at an application, I would try and get as much of this information as I could before I could make a good determination on what we're looking for. Once I have that information, I would probably go to the actual bearing manufacturer's maintenance manual, and it may give us something like this. It may tell us specifically what grease we want to use. So this doesn't tell us an NLGI, number 1, number 2, or the type of grease. This just gives us a manufacturer. So if we didn't have these available, or we wanted to select something else, we'd need to go to the internet and find something that was compatible or similar to any of these greases. So, and from this chart, you can probably see we have like a number 1. So perhaps that's an NLGI number 1. We have some other indicators in here, like an EP2. That would probably be an extreme pressure additive in there. So if we couldn't find those, these manufacturers, we may know at least that we're dealing with an NLGI 1, maybe an NLGI 2, maybe we have an extreme pressure grease. If it didn't give us a specific grease to use, maybe it tells us the type of grease and the NLGI number, as this does. This is again from a maintenance manual. It tells us the original grease was an NLGI number 2 lithium complex, but it also tells us it needs to be suitable for roller bearing service. So that's another important part of the description. So from what we know so far, what grease are we wanting to use? Well, we probably want to use a good quality grease, an NLGI number 2, a lithium complex, extreme pressure additives, suitable for roller bearings or anti-friction bearings. So when we have this information and we go to the store, what are we going to look for on the side of the package? Hopefully, we can read the description and look for the thickener type. So then we'll know what type of grease it is. It doesn't always tell that on the side. We can look for the words matching our application. So does it say it's for anti-friction bearings? Does it say it's for, say, medium speed bearings or high speed bearings? Another good source is to take our grease and we can look it up on the internet. If we go look at that manufacturer's website and type in a search for the data sheet, typically we can find a data sheet that's going to give us the information that we're looking for. If we can't find a data sheet off the internet, perhaps we can go and call the actual manufacturer and request that data sheet. So, as an example, for our bearing for our bearing application, here's an example of the wrong lubricant to use. And the reason why is because it says it's well suited for small equipment that does not require extreme pressure additives. So another example of a lubricant to not use on our specific application. This one calls out and says that it is an extreme duty 3% molybdenum disulfate. Well, the reason this would not be suitable for our application is because the molybdenum or moly is a solid lubricant, and typically in roller bearings, we don't really need to use a solid lubricant in that case. So molybdenum disulfate, 3% molybdenum disulfate greases or 5% molybdenum disulfate greases are typically used in, say, pins on a tractor or any other equipment, something with heavy loads that doesn't move very fast. So that'd be the reason we wouldn't want to use this one. For this bearing example, this would be an example of the right lubricant to use. And the reason why is because of this line here protects both plain and anti-friction bearings. And then this line where it says demonstrates superior EP characteristics. Here's an example of a data sheet for grease. So first thing we would look for is what type of grease this is. And at the top right in this particular one, you can see that it's a lithium complex. Come down a couple lines and we can see that NLGI grade. It gives us a lot of information on the right hand side as well, as far as viscosity index and its performance, and you could use this to compare against other greases if you wanted. On the left hand side on this one, you can see you would also get some of that data, or excuse me, some of that text that would hopefully give you a description of what this grease is used for. All right, so the right amount. Again, we'll go back to the maintenance manual and we could look at our bearing, look up the part number, look up the size, come over here, and we would see how many cm cubed or cc's of grease to use. In this case, it's telling us this bearing would be somewhere in the 39.7 or 40 cc's every 4 months. We could also download an application. What? We can also download an application and put in our data, and it will give us the correct amount of grease per day to use. The right time. Here we are back at our maintenance manual, and it gives us how often to grease this So we would go to our conditions, our moisture, what temperature is being operated at, and we would get how often to lubricate this bearing. So this is from the Dodge bearing example that we got. In its manual, this is exactly what it says. When establishing a re-lubrication schedule, note that a small amount of grease at frequent intervals is preferred to a large amount of grease at infrequent intervals. So, the right place. Here we are back at our example, and we want to make sure we get our grease in the right place. So if I'm a young grease tech and I'm inexperienced, and I go up with my grease gun and I go to grease the shaft bearing, I'll put it in here, and maybe I see a couple other grease zerks up there. I may make the mistake of putting it in the wrong place because this particular application may call for polyurea. So keeping it in the right place is important. And then also the right condition. So again, I'm the inexperienced lube tech, and I go up here and just start pumping grease. I'm going to get this debris inside that bearing, and I don't really want to do that. So I would need to make sure I do a good job of cleaning these grease zerks off before putting grease in there. All right, so what grease is in this gun? So if I'm an inexperienced lube tech, I may just go grab any grease gun, and I don't know what grease is in here. Again, if I have multiple greases at my site, it'd be very easy to get these crossed up and get a cross-contamination of the grease. So the solution for that, grease guns with a clear tube so that you can see and identify what's inside that grease gun. Now, automatic lubrication. This is a multi-point automatic lubrication unit. These are great to take that responsibility of when to grease something and how much to grease it off of the lube tech, and it automates it. We have a tank for the oil, we have a pump, we have a controller that sets the pump to turn on and off at the correct time. We have multiple lines going out to the unit. This type of system, there's a little more expense in the unit, there's a little more expense in the installation, but it's a great solution when you have multiple grease points or lube points in this case. Single point automatic lubricators. So this is a great solution that's very economical. This can be put directly on a bearing. It's going to lubricate every day continuously. It can be remote mounted. There's another remote mount location there underneath the caps. But this is not going to, again, forget to go lube this. It's not going to call in sick. That's why this type of lubrication is really beneficial. So how do they work? So this is one of the single point automatic lubricators taken apart. You can see the lube cup, we have a battery, we have a drive head. So we have the top of the drive head here. There's a button there to put the correct settings. When this particular unit is used, we remove the lube cup, remove the battery, put a new battery, put a new lube cup, and within probably 2 minutes, it's back in operation. So why to use single point lubricators? Get a drink here. First off, climbing to the top of this involves loading up something to hold all your equipment, your cleaning rag, your grease gun, and somehow you got to get it all the way to the top. And this particular bearing probably needs to be greased when it's being used in the season at least once a month. It would be more optimal to grease it at once a week. But that's a lot of work to climb up the top of that. So put a single point lubricator on the top of there, and you could potentially just have to change that once every 6 months. Another reason to use it. So remember that example of the dirty greaser. That's eliminated now because this is covering it up. There's no opportunity for contamination to get in while this is connected. And when you remove it and put a new one on, the opportunity for that contamination to get in there is very low. So this is probably the best reason why to use this. Is again going back to this Dodge bearing maintenance manual, where it specifically says, and this is in many other maintenance manuals for other bearing manufacturers, when establishing a relubrication schedule, note that a small amount of grease at frequent intervals is preferred to large amount of grease at infrequent intervals. So this single point automatic lubricator is going to put a small amount of grease continuously throughout the day, week after week, month after month. This will lubricate your bearings much better than using a grease gun, and you'll end up having a bearing that's going to last you a lot longer. All right, so that's the conclusion. Do we got any kind of questions?